Okay, so we are starting a second semester, and we are going to be starting Unit 2, which is parametric equations, and being able to do the calculus with parametric equations. So what I want to do first is give you a lesson on what are parametric equations to begin with, because I want you to know what they are before we start doing the actual calculus with them. So this is like an introductory lesson on what parametric equations are. So our outcome is I can sketch a parametric equation, indicate the direction, and find the Cartesian equation. So this is what are parametric equations. All right. So the basic definition of what parametric equations are, they are a pair of equations used to describe a curve. So we've got an x equation and we have a y equation, and they're both given as functions of a third variable. We often use a t, don't have to be a t, but we often use a t, and that's called a parameter, which is why it's called parametric equations. So you're basically representing an x and a y value in terms of a third letter. That's all it is. So as t varies, so t is your independent variable, and x and y are both the dependent variables. So as t varies, then that will determine what your x and y values are, which determines the points x and y, that when you graph them, it will trace out the parametric curve. All right. So again, this is just dealing with x and y coordinates, but those x and y coordinates are described in terms of a third variable, often a t. Okay. So now that was the gist of the content part. So I'm not going to make two videos. I'm going to go straight into the examples because that was all there was for just that little part. All right. So this first thing, for example 1, says to sketch and identify this curve given these two parametric equations. So notice the x function is t squared minus 2t, and the y function is t plus 1. So they're both x and y are written in terms of a third letter t. So the first thing we got to do is we're just going to make a t chart. All right, and we're going to have t, x, and y. And all you're going to do is pick selected values of t, and you're just going to plug them in and figure out your x and y coordinates, and then you're going to graph them. That's all there is to it. All right, so I'm going to do some problems. So I'm just going to do 0, 1, 2, 3, and 4, and just see what happens there. So you're going to plug 0 into both of these, and you're going to get 0 and 1 when you plug 0 into both of those. I'm going to plug 1 into both of them, and when I plug 1 into both of them, I get -1, 2. When I plug 2 into both of these, I get 0, 3. When I plug 3 into both of these equations, I get 3, 4. And when I plug 4 into both of those equations, I get the coordinates 8, 5. And t does not have to be positive, okay? So I'm going to do a couple of negative values of t as well. All right, I'm just making sure I'm copying the table right. Okay, I'm going to choose some negative values. So I'm going to do -1 and -2 just to see what I get. So let's see, I think I did those coordinates right because I wrote them outside my t table. So if we put a -1 in here, we get the answer 3, okay? And we put a -1 in here, we get 0, okay? So I did do it that way. And then for -2, if I plug -2 into both of these, I get 8 and -1. All right, so all I've done is I picked selected values of t, I substituted them into the functions x and y, and now we're just going to graph what that does. So now I'm just going to graph a picture of what that looks like. So for this section, it might be helpful if you had some graph paper, might be a little bit helpful to do these problems, but you don't have to. All right, so what I'm going to do is I'm just going to graph these and see what happens here. I've got 0, 1, so I'm 0, 1 right here. And then I'm -1, 2. So that means it's connecting from here to here. And I'm traveling this way. Then I'm 0, 3. So then I'm 0, 3, traveling that way. And then we're 3, 4, traveling that way. 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. So 8, 5. and we're traveling in this direction, and we're going to keep going in that direction. So then when I graph these over here for the -1 and the -2, I was at 3, 0, and then I was at 8, -1. So 8, -1 would be down here. And so this was traveling this way. So this was when t was -2. This is when t is -1. And it's coming this way, traveling this way. So you put the little arrows on here to show which way this thing is traveling. So this is when t was 0. It just helps to label a few of them. Up here, this is when t was 4, and this was when t was 3. And so obviously, if you think this is going this way, it's traveling this way, going around. It looks like a sideways parabola. All right. So now, we've sketched and it identified the curve, looks like a sideways parabola. So what I would like to do now is I would like to put these together and show you what equation you get. So now I'm going to solve this equation for t. So if I solve this for t, t is going to equal y minus 1. So now I'm going to substitute this into the x equation. So x is going to equal, t is y minus 1, so this will be y minus 1 squared minus 2 times t, t is y minus 1. So I took the y equation, because it was the easiest one, and I solved for t by just moving the 1 to the other side. And then I'm substituting this expression in for t into the x function. So I'm actually combining them and putting them together. And so when you multiply all this out, I won't do all the math, but if you multiply it all out, you end up with y squared minus 4y plus 3, which we know is a sideways parabola. X equals y squared. It's open to the right because it's a positive y squared, so it matches exactly our picture that we got. So this is parametric equations. It is 2 equations written in terms of a third of variable. One equation gives you your x coordinate, the other equation gives you your y coordinate, but it also shows movement along the curve. So as t increases, you have to show the arrows of which way you're moving along the parametric equation, along that curve. That's the only difference from just graphing a regular problem. All right, is you got to show the direction and the movement. All right, so number 2 says, what curve is represented by the following parametric equations? All right, so easiest thing we could do, we could graph it and see what happens. All right, so if I were to make a little t chart here, like I did before, I would have t, x, and y. All right, and I'm just going to put some selected values on here. I'm going to put t, I'm going to do pi over 4. Notice I'm doing pi because the t is the radians behind the trig function. So now I'm doing radians. So 0, pi over 4, 3 pi over 4, and pi. So I just picked some values for t. All right, so then I plug 0 into both x and y and just fill in the t chart. So I got 1, 0. And then here I got radical 2 over 2 and radical 2 over 2, because these are just the functions off the unit circle. And then negative, whoops, I'm not keeping in line with myself, negative radical 2 over 2 and radical 2 over 2. And then for pi, negative 1, 0. So then if you sketch it, all righty, so we know radical 2 over 2, that's about 0.7. So that's approximately 0.7. Approximately 0.7. So this will be approximately negative 0.7, because radical 2 over 2 is what I'm doing, radical 2 over 2. So that's approximately negative 0.7, and this is approximately 0.7. All right, so if I'm graphing these are all 1 unit, right? That's as far as I got to go. So I'm at 1, 0, so I start here at 1, 0. And then I'm at 0.7, 0.7, so that would put me over 0.7, up 0.7, about here, and I'm moving in this direction. So I'm moving this way. And then the next one, I'm at 0, 1, and I'm moving this way. And then I'm at negative 0.7, positive 0.7, so here, and we're moving in this direction. And then I'm at negative 1, 0, so we can already tell as we're figuring this out that that's a circle. So this is going to end up being a circle where we're moving in this direction. So I really don't even have to go through all the points, just showing that, just doing just the few points, 0 to pi, obviously gave me that much of our circle. All right, so how do we get our equation for this? Well, use your knowledge of what you know. what do we know about sines and cosines? We know that sine squared plus cosine squared equals 1. So now I can just plug these in. Sine squared is going to be y squared. Cosine squared is going to be x squared equals 1. So it's the equation of a circle with radius 1 centered at the origin, and that's exactly what we got when we graphed it. All right, so all I did was just converted from parametrics into rectangular coordinates, normal Cartesian coordinates. All right, same one here. What curve is represented by the following parametric equations? All right, so same thing, do the little T chart. And I'll try to go through this and just fill in the chart. Whoops, T first. Just fill in the chart for you. So T, X, and Y. So pick selected values of T again. So pi over 4, pi over 2, 3 pi over 4, and pi. And of course, we're going 0 to pi like we were on the last one. But maybe if I just see that part, I'll know what I'm doing. So I've got 0, 1. Yeah, this one's a little bit harder. 1, 0. Then this is 0, negative 1. This is negative 1, 0. And this is 0, 1. All right, so if I sketch this, I'm going out 1 in all directions. So I start at 0, 1 up here, and then I'm at 1, 0, so I'm over here moving this way. And then I'm at 0, negative 1, so I'm down here moving this way. And then I'm at negative 1, 0, coming up here. And then I'm at 0, 1 again. Well, notice I've gone around already one full time, but I'm supposed to go to 2 pi. So I've already gone one full circle all the way around, just going 0 to pi. So if I go to 2 pi, I'm just going to retrace and go around this thing a second time. So I'm basically going around this circle twice. So I've got a circle here, and it's mapped twice on 0 to 2 pi. Because I've already done 0 to pi in my table, and I've gone around already one circle all the way around. So if I go if I keep going more points up to 2 pi, it's going to just trace around a second time. That's all it is. All right. And you could still put sine squared plus cosine squared. You're going to get x squared plus y squared equals 1 again, which is a circle, unit circle. All right. Now, notice it went around twice, and that's because we were doing 2t. You'll notice that connection too. That changes how many times you go around based on this parameter in there. All right, so that was number 3. Number 4 just wants us to come up with our own parametric equations. Find some parametric equations for the circle with center at HK with radius R. All right, so do we know the formula for the circle? So a circle is x minus h quantity squared, and then it's y minus k quantity squared equals r squared. That's the equation of a circle that has center HK with radius R. That's the standard equation of a circle. So what we want to do is we want to create parametric equations for this. All right. So the simplest thing to do would be to think of it like sine squared plus cosine squared equals 1. So what I would need to do is make this 1 right here. So let's divide everybody by r squared. All right. So then we've got x minus h squared over r squared. Y minus k squared over r squared equals 1. So now if you connect this to something you already know, this would be your sine squared, because sine's the y coordinate. So sine squared t would be there. And then this would be our cosine squared. So comparing these together now, I'm getting that my cosine squared is going to be equal to the x minus h squared over r squared. That's going to be that part. My sine squared is going to equal this part here, the y minus k squared over r squared. So now I can figure out that cosine of t, since I can take the square root of everybody now, is going to be x minus h over r. And over here, these are all squared, so I can take the square root of everybody. So sine is going to be y minus k over r. All right? And so now we need to solve for x and y to get our parametric equations. So I'm going to multiply the r over here. So r cosine will equal x minus h. And then you're going to add your h. So x is going to equal h plus r cosine t. So there's my x equation. Then over here, I'm going to do the same thing, solve for y. So I'm going to multiply the r over here. So r sine t equals y minus k. And then add the k over here. So k plus r sine t would equal my y. So there's my y equation. So these are parametric equations, one for x and one for y. They're written in terms of t for any circle with center hk and radius r. So that would be a generic pair of parametric equations for the circles. And your t would go from, our t would go from 0 to 2 pi. Okay, and that would circle you one time around your circle. All right, so that's how you get parametric equations. You just got to somehow separate your equation that you have and get a separate equation, one from x and one for y, that are written in terms of t. Now, these have h's and r's and k's in it just because we were doing a generic one for a circle. So the last one, number 5, says sketch and identify the curve defined by these parametric equations. All right, so this time we've got sine squared. So we'll see what that does here. So make a new t-chart first, and I picked quite a few points for this one just to see what would happen. So you're going to do a t-chart every time. So I picked 0, and then I did pi over 4, and then I did pi over 2, 3 pi over 4, and then pi, but I kept on going and did more than that. I did, after that I did 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. I went and did values all the way through 2 pi. So these were, all I did, remember, is I'm plugging in these numbers in for x, finding the x coordinate, plugging in this number into the y equation, found the y coordinate. So I'm just plugging those into these two equations and figuring out the two coordinates. So I'm going to fill them in for you. Radical 2 over 2 and then 1/2 here. For pi over 2, it's 1, 1. For 3 pi over 4, it's radical 2 over 2 and 1/2. For pi, it's 0, 0. For 5 pi over 4, it's negative radical 2 over 2 and 1/2. For 3 pi over 2, it's negative 1/2, negative 1, 1, excuse me. For 7 pi over 4, it's negative radical 2 over 2 and 1/2. And then for 2 pi, it's 0, 0. So again, that's just plugging in these t values into each of these parametric equations and getting the x coordinate and the y coordinate. So now when you come over here and sketch what this does, so my biggest number I go out is 1, so that's all I need for my tick marks. So I start at 0, 0. So that's where I start when t is 0. And then I go to radical 2 over 2, 1/2, which that's going to be 0.7, 0.5. So I'm going to go over 0.7 and up 0.5. And so I've moved up to here, and I'm moving in this direction. And then I get to 1, 1. So then 1, 1, get to 1, 1. I've moved here, and I'm going in this direction. Then I come back to radical 2 over 2, 1/2. So then I travel back to this point here. That's 0.7 and then 0.5. And so then I trace back this way, get back to the origin again. So I'm tracing back to the origin. And then I'm going to negative radical 2 over 2, 1/2. So that'd be negative 0.7, positive 0.5. So then I'm traipsing up here, moving in this direction. And then I get to negative 1, 1. So I'm going up here, moving in that direction to the left. Then I'm going to come back down to negative radical 2 over 2, 1/2. So then I'm coming back down to this point. So now I'm traveling back down here. And then I come back to the origin again. So then I'm traveling back to the origin. And that's only going from 0 to 2 pi. So I started at the origin, I swung up this way, then I came back down to the origin, and then I swung up to the left this way, and then I came back down to the origin again. All right. So what we're doing is moving along this curve, just swinging back and forth is what happens. All right. So if you look, putting these two equations together to show you what this is, notice x is equal to sine, but also notice that y is equal to sine squared. So if x is sine, then that means you're replacing sine with x, so y is going to be x squared because x is sine. So you replace sine right here with an x and you get x squared. So it is the parabola y equals x squared, which is exactly what we got in our drawing, except we are only moving between for our x value, we are only moving between -1 and 1. And we are moving infinitely back and forth. So we are infinitely moving back and forth. So it infinitely moves back and forth between -1, 1 and +1, 1 and going through the origin. It just keeps swinging like a pendulum back and forth. All right. So it's on the parabola. It only goes between -1 and 1 on the x-axis, and it just infinitely moves back and forth like a pendulum on there. Okay, so this is parametric equations. So now I want you to play with the calculator. If you have a graphing calculator, I want you to use parametric mode on the graphing calculator, and I want you to type in these two equations for x and y. And then this is what you want to put in your window. You want your t to go from 0 to 2 pi, and you want it to go steps of 0.01. That just means we want our dots really close together to really get a nice picture. And then the window fitting, we want our x minimum and our x maximum to be -2.25 and +2.25 with a scale of 1. And then you want your y min and max for your window to be -1.5 and 1.5 with a scale of 1. So this is what you put in for your window. This is what you put into the y equals screen, but you've got to change the calculator first to parametric mode. All right. So you've got to change your calculator to parametric mode. So I'm going to click through here and show you. So when you go to mode, you want to change from function to parametric. That's the only thing you have to change on that screen. And once you change it, it's going to stay there. So if you ever need to go do something in regular function mode, you have to go back into your modes and change it back to function. All right. Then in your y equals screen, you want to type the two equations that were there. And then on your window, you want to type in those numbers that I gave you. So 0 to 2 pi with the 0.01. So you want to type those in, and then you're able to graph it. All right. You're able to graph the function. So get those functions typed in, have a little time playing with those, and get the picture. I'll show you what the picture looks like because I have it on here. So when you type graph, this is what you get. So that's pretty cool. So this is using parametric equations, gives us like a little spirograph looking like thing. If you ever played with the spirograph, I played with that when I was little, made little designs with a spirograph. All right. And then there's another one, number 7 on here, another one for you to try. Use parametric mode again, but you already got it in parametric mode, so you shouldn't have to change it. It already stays in that until you change it back to function mode. So now for y1 and y2, for your two equations, you want to type in for x and y these two functions. They're a lot shorter, so that won't take near as long. And then here's your new window. And then you want to graph and see what that particular looks like. So we can put parametric functions into the graphing calculator as long as you tell the graphing calculator that you're doing parametrics. So you just have to put it in that mode, and then it automatically will do t's. When you type the x button on the calculator, it automatically types in a t now instead of an x. So these are your y equals screens for the two functions for x and y. Here are your windows. So on your y equals screen, just type those in for x1 and y1. And then you want to type those into the window, get those numbers typed in there. And then when you press graph, you should get something that looks like that. All right. So this was a lesson over parametric equations. Just what do they look like? What are they? Because we're going to be doing some calculus with parametric equations. So I wanted you to know what they were before we actually start doing some calculus. So you have some practice problems to do. This is the assignment that's on Canvas, page 641, 1 to 15 odd. So just to do some practice with making a table and graphing a parametric equation. And the important thing about a parametric equation, you also have to draw the arrows of which way you're traveling along the curve, all right, as t increases. All righty, so there's your assignment. Good luck.